Hi, I'm Mac.
And I'm Wesley, and we approve this video. This is our spruce main board, and you'll notice this is the UV PCB. We're making an oven for the physics department at Weber State University, and he needs his pretty quick, so we went ahead and had to accelerate the build of this thing, even though we wanted to show you guys how to build it on the video. But let me go over some of the components, parts, and pieces here. I'll start from the bottom and go to the top. This 4-pin male header we have right here, and these two resistors control the LED. Excuse me, the two LEDs on the front of the project box. You have one LED is red, that is either steady or flashing depending on how hot the oven is. The other one is a green one, that is a power. We have a resistor here that helps provide current to these two triacs. So this resistor goes for this resistor is for this triac here. These are really solid state relays. There's a little LED inside. When the LED comes on, it allows power to flow here. So we hook up one coil here of the oven, the other coil here to the oven, and these triacs is what controls the oven, turning it on and off. One of the triacs controls the top burner, the other triac controls the bottom. Each of these can handle 8 amps, so that should be plenty for the oven. Here's our 20 megahertz crystal with the two 22 picofarad capacitors for it. You'll see these little terminal blocks that we have here. These are completely optional. If you want, what you can do is not include those, and on the pads here for the terminal blocks, you just drill a bigger hole in there. You'll notice we made the pads fairly big, fairly good sized. That way so you can just put the wire and just solder it directly to the board instead of using these terminal blocks. Here is our microcontroller. We went ahead and used a 40-pin socket for our microcontroller. Weber State University had a sale of excess equipment. So I ended up with maybe about 50, 60 of these things. So I kind of want to get rid of them. So I put it into the project. Here is a jumper. Right here, don't forget the jumper when you're soldering. And this jumper goes into this 8-pin male header here. We also have another 8-pin male header here. These are two 6-pin male headers. These two 6-pin headers go to the LCD. We have these two potentiometers here. One of them controls the brightness of the backlight on the LED. Excuse me, the LCD. The other controls the contrast of the letters and numbers, the printout. Here we have an 8-pin male header for our 4x4 keypad. You'll also notice we have 4 diodes, 4 more resistors over here. These actually go to help control the 4x4 keypad that the microcontroller sees. I want to point something out to you here quickly. Jump ahead a little bit. We have a diode here and a diode here. This diode here is a reverse polarity diode. So if you hook the power up wrong here, it's not going to fry everything out in the board. You can only hook it up in the correct direction. So I believe this is your negative terminal. This is your positive terminal that comes off of your 12-volt power supply. And Mac and I use a 12-volt wall wart, 800 milliamps to get this thing going. But let me show you these diodes real quick. Here is the reverse polarity diode. You notice it has a little silver stripe right there. When you solder this, make sure the silver stripe points towards the terminal block or the place that you're going to solder the leads for your power supply. The second one, and it's really hard to see, this little guy is called a BAT85. It's a diode on your keypad, and it's kind of small, but if you look real close over here to your right hand side, you'll see a little black stripe. When you solder these in, make sure the black stripe is pointed towards the microcontroller. And as we go up, we have a 5-pin header here. This 5-pin header is nothing but a programming interface to program the chip while it's still on the board. We have 2 resistors here. This resistor goes to the reset on the microcontroller. You're really not going to do anything with that. The other is a 1 kilo ohm resistor that goes to the thermistor block here. This sets up a voltage divider with the block here, so it makes it easier for the microcontroller to read it. Here is our voltage regulator. It's a 7805. It steps on our 12 volts down into 5 volts. This thing will handle 1 amp. It's plenty for the board. We also have 2 capacitors here to help the voltage regulator regulate the power supply. And I want to talk a little bit about these 2 capacitors here. This capacitor is polarized, just like these diodes. It means it has a positive and a negative, and it is possible to put this thing in backwards. Now you can use any diodes, or excuse me, any capacitors that you want here. You just got to make sure that if they are polarized, you put them in correctly. Here are 2 capacitors here. And you'll notice this capacitor here, the leads are the same length. With leads that are the same length, it means this capacitor is not polarized. So it doesn't matter if this is positive or negative. This capacitor, on the other hand, is polarized. Alright, I'm going to explain one more thing to you, and then we're going to turn it over to Mac. We have 2 drill bits here. We have the 0.0453 inch drill bit here. We have another one which is 0.0354 inches here. I got them from Harbor Freight. You get a whole set of these drill bits. They come in a package like this. It'll cost you $8 for a whole bunch of them here. You really only need these, is all you need for doing circuit boards. But what you're going to do is you're going to use this larger drill bit here, the 0.0453, and you're going to drill these set here. Instead of the sockets, the blue sockets that I showed you earlier with the screw that you could just plug right in, if you want to just solder the wires directly to the circuit board, just use a 3/16 inch drill bit and drill those out, and you should get the wires in there pretty quickly. We also use this larger drill bit here. This is the diode. That diode has some pretty big leads to it, so you want to use the bigger drill bit. Smaller drill bit for everything else, and everything should fit perfectly. Something I also want to explain here to everybody is after you finish drilling this thing, what you want to do is you want to take your components, like this diode here, and you want to test fit them into the holes to make sure the leads fit. It's really difficult to drill anything on the circuit board at all after you have even 1 or 2 components in it. If you try to enlarge a hole, it's pretty impossible. So after you drill your holes, take your pieces and test fit them into the holes to make sure they fit. If they fit, I mean test all your pieces, not just 1 or 2. Test them all. Once you get all of them fitting, then go ahead and start soldering your circuit board.
When you're soldering, you actually want to make sure that you're placing it on this back side rather than on the green side, as we've kind of been putting our main focus to. On pages 19 and 20, you're going to find the parts list, which is going to label all the parts. And then on page 20 is our schematic, and it actually labels all the parts where they're supposed to go. But you have to remember that it is mirrored for the back side of the circuit board.
Here's a quick tip for you. Here is our circuit board, and you'll notice that we haven't drilled any of the holes for the components yet. But we have drilled the holes here. We used a 1/8 of an inch drill bit. And this is what you're going to use. These holes right here and some standoffs is what you're going to use to mount it inside this project box. So here's that Radio Shack project box that's in the parts list. And here's your circuit board. You're actually going to flip it over like this, position it where you want in the project box, grab a drill with the 1/8 of an inch drill bit, come in here and drill some holes in right there. The holes here in the bottom are for the standoffs that's going to hold this thing. Now you notice you want to put it with the traces side up, because when we put this in the project box, what it's going to look like is it's actually going to sit down inside here like this with the components facing upwards. So before you start drilling this, before you start soldering this, make sure you put your mounting holes in your case first.
Okay, so as you can see, we've already drilled all of our holes here, and I've taken some blue tape and actually taped down our diodes and put the leads through to the other side. And I've already gone ahead and put a little bit of flux on each of these solder pads so that way we can solder them. And I like to use the blue tape so that way nothing comes out. And now is just get some solder. Right, so with these little leads, it's fairly easy to solder. You just have to set it down. And then with the larger leads, they take a little bit longer, so you have to solder both sides. Once you're done soldering, go ahead and remove the tape. And then get a pair of wire cutters, and you'll actually cut kind of parallel down to the board. And then with the polarized components, such as the diodes and a couple of the capacitors, be very careful that you put them in the correct way, or else you might burn up a circuit board. Wesley did one yesterday.
I heard that!